actually, there's an important experiment that that drives a lot of what people want to do with brain-machine interface, and that's the work of Bill Newsom, who is at Stanford, and Tony Movshin, runs the Center for Neuroscience at NYU. This is a wild experiment, and I think it might freak a few people out if they really think about it too deeply. But anyway, here it goes. There's an area called MT in the cortex. And if I showed you a bunch of dots all moving up, and this is what Tony and Bill and some of the other people in that lab did way back when, is they show a bunch of dots moving up. Somewhere in MT, there's some neurons that respond. They fire when the neurons move up. And then what they did is they started varying the coherence of that motion. So they made it so only 50% of the dots moved up and the rest moved randomly. Mm-hmm. And that neuron fires a little less. And eventually it's random and that neuron stops firing because it's just kind of dots moving everywhere. It's awesome. And there's a systematic map so that other neurons are responding to things moving down and other things are responding left and other things are moving right. Okay. So there's a map of direction space. You go, okay, well, that's great. You could lesion MT. Animals lose the ability to do these kind of coherence discrimination or direction discrimination. But the amazing experiment, the one that just is kind of eerie, is that they lowered a stimulating electrode into MT, found a neuron that responds to when dots go up. But then they silenced that neuron. And sure enough, the animal doesn't recognize the neurons are going up. And then they move the dots down. They stimulate the neuron that responds to things moving up. And the animal responds, because it can't speak, it responds by doing a lever press, which says the dots are moving up. So in other words, the dots are moving down in reality on the computer screen. They're stimulating the neuron that responds to dots moving up. And the perception of the animal is that dots are moving up, which tells you that your perception of external reality absolutely has to be a neuronal abstraction. It is not tacked to the movement of the dots in any absolute way. Your perception of the outside world depends entirely on the activation patterns of neurons in the brain. And you could hear that and say, well, duh, because if I stimulate, the stretch reflex and you kick or something or whatever, the knee reflex and you kick, of course, there's a neuron that triggers that, but it didn't have to be that way. Yeah. Because A, the animal had prior experience. B, you're way up in this, higher order cortical areas. What this means is that, and I generally try and avoid conversations about this kind of thing, but what this means is that we are constructing our reality with this space-time firing, the zeros and ones, and it doesn't have to have anything to do with the actual reality. And the animal or person can be absolutely convinced that that's what's happening.
Are you familiar with the work of Donald Hoffman? So he makes an evolutionary argument that's not important of that our brains are completely detached from reality, in the sense that he makes a radical case that we have no idea what physical reality is, and in fact is drastically different than what we think it is.
Oh my.
So he goes,
that's scary.
So he doesn't say like there's just, because you're kind of implying there's a gap. Mm-hmm. There might be a gap. We're constructing an illusion and then maybe using communication to maybe create a consistency that's sufficient for our human collaboration, whatever, or mammal, just maybe even just life forms are constructing a consistent reality that's maybe detached. I mean, that's really cool that neurons are constructing that, like that you can prove that. This is what neuroscience at its best, vision science. But he says that like our brain is actually just lost its shit on the path of evolution, to where we're just playing games with each other in constructing realities that allow our survival, but it's completely detached from physical reality.
Like we're missing a lot.
We're missing like most of it, if not all of it.
Well, this was it's fascinating because I just saw the Oliver Sacks documentary. There's a new documentary out about his life. And there's this one part where he's like, I've spent part of my life trying to imagine what it would like to be a bat or something, to see the world through the the sensory apparatus of a bat. And he did this with these patients that were locked into these horrible syndromes, that to pull out some of the beauty of their experience as well, not just communicate the suffering, although the suffering too. And as I was listening to him talk about this, I started to realize, it's like, well, what, like there are these mantis shrimps that can see 60 shades of pink or something, and they see this stuff all the time. And animals that can see UV light. Every time I learn about an animal that can sense other things in the environment that I can't, like heat sensing, whatnot, I don't crave that experience the same way Sachs talked about craving that experience. But it does throw another penny in the jar for what you're saying, which is that it could be that most, if not all, of what I perceive and believe is just a neural fabrication, and that for better or for worse, we all agree on enough of the same neural fabrications in the same time and place that we're able to function.
Not only that, but we agree with the things that are trying to eat us enough to where they don't eat us, meaning like that it's not just us humans, right?
I see, because it's interactive.
It's interactive. Now I think it's a really nice thought experiment. I think because Donald really frames it in a scientific, like he makes a hard, like as hard as our discussion has been now, he makes a hard scientific case that we don't know shit about reality. I think that's a little bit hardcore, but I think it's
It is hardcore. It is hardcore.
I think it's a good thought experiment that kind of cleanses the palate of the confidence we might have about because we are operating in this abstraction space, and the sensory spaces might be something very different. And it's kind of interesting to think about if you start to go into the realm of Neuralink, or start to talk about just everything that you've been talking about with dream states and psychedelics and stuff like that. Which part of which layer can we control and play around with to maybe look into a different slice of reality? You
just got to do the experiment. The key is to just do the experiment in the most ethical way possible. You just, that's the beauty of experiments. This is why, there's wonderful theoretical neuroscience happening now to make predictions, but that's why experimental science is so wonderful. You can go into the laboratory and poke around in there and be a brain explorer and listen to and write to neurons. And when you do that, you get answers. You don't always get the answers you want, but that's the beauty of it. I think when you were saying this thing about reality and the Donald Hoffman model, I was thinking about children, like when I have an older sister, she's very sane. But when she was a kid, she had an imaginary friend.
Yeah.
And she would play with this imaginary friend. And there was a consistency. This friend was like, it was Larry, lived in a purple house. Larry was a girl. It was like all this stuff that a young child wouldn't have any issue with. And then one day she announced that Larry had died, right? And it wasn't dramatic or traumatic. And that was it. And she just stopped. And I always wonder what that neurodevelopmental event was that kept her out of a psychiatric ward had she kept that imaginary friend. Yeah. But it's also, there was something kind of sad to it. I think the way it was told to me, because I'm the younger brother, I wasn't around for that. But my dad told me that there was a kind of a sadness because it was this beautiful reality that had been constructed. And so we kind of I wonder, as you're telling me this, whether or not as adults, we try and create as much reality for children as we can so that they can make predictions and feel safe, because the ability to make predictions is a lot of what keeps our autonomic arousal in check. I mean, we go to sleep every night and we give up total control, and that should frighten us deeply. But, unfortunately, autonomic arousal yanks us down under, and we don't negotiate too much. So you sleep sooner or later. I don't know. I was a little worried we'd get into discussions about the nature of reality, because it's interesting in the laboratory. I'm very much like, what's the experiment? What would what's the analysis going to look like? What mutant mouse are we going to use? What experience are we going to put someone through? But I think it's wonderful that in 2020, we can finally have discussions about this stuff and kind of peek around the corner and say, well, Neuralink and others who are doing similar things are going to figure it out. They're going to, the answers will show up, and we just have to be open to interpretation.